So problem 4 says you have to find the equation of the tangent line to the graph of x cubed times y squared minus y cubed equals 4 at the point 2 comma 1. So the first thing to realize is that when you want to find the equation of your tangent line, you need to plug in the point, namely, in this case, your x and y values into the derivative. To get the derivative of this equation, you got to apply something called implicit differentiation. That's right. So you have to take the derivative with respect to x of this entire equation. That's the first thing you like to do. So if I want the derivative of x cubed times y squared, I need to apply a product rule. So the product rule says that I'm going to keep x cubed and I'm going to take the derivative of y squared. When I take the derivative of y squared, it's going to be 2y dy dx. So you can probably use y prime. I preferably use dy dx. Then you keep your 2y, you keep your y squared and take the derivative of x to the third, which is 3x squared, minus the derivative of y cubed, so that's going to be 3y squared dy dx is equal to 0. So I'm just going to clean this up a little bit. We did the calculus part. Now the rest of this problem just literally becomes arithmetic and algebra. What we have is x cubed times 2y times dy dx. So you can rewrite that as 2, the constant first, variable x, variable y, then dy dx, plus y squared times 3x squared. So it's 3x squared y squared. And then you have minus 3y squared dy dx is equal to 0. So what I'm going to do is rewrite this equation where I have, sorry, this is squared. You have your dy dx by itself. So what you're going to do is, well, this is the only term that doesn't have a dy dx. So I subtracted on both sides. When I do, this will cancel. This will give us 2x to the third y dy dx minus 3y squared dy dx is equal to negative 3x squared y squared. Now, from the left-hand side of the equation, you could factor out the dy dx. You'll have 2x cubed y minus 3y squared is equal to negative 3x squared times y squared. So we're almost done with the first part of this problem. The first part was just getting our dy dx. So if you divide what's inside the parentheses on both sides of the equation, dy dx is equal to negative 3x squared times y squared over whatever's inside that parentheses, which is 2x cubed times y minus 3y squared. Good. You have your derivative. Now what you're going to do, right, this was all step 1. Step 2 now is to get the slope of your tangent line. So m tangent is equal to dy dx evaluated at the point 2 comma 1. So wherever I see an x, I'm replacing with 2. Wherever I see a y, I replace it with 1. So therefore, we're going to get m tan is equal to negative 3 times 2 squared times 1 squared over 2 times 2 cubed times 1 minus 3 times 1 squared. So in the numerator, let's see. 1 squared is 1. 2 squared is 4, so that's 4. 4 times negative 3 is negative 12. In the denominator, you have 2 times 2 cubed. So 2 to the third is 8. 8 times 2 is 16. 16 times 1 is 16. 1 squared is 1. So 1 times negative 3 is minus 3. So what you're going to get as an answer is negative 12 over 13. That will be my m tan. So that's your second step. The third step now, I got to zoom out a little bit, is to actually write out the equation of the tangent line. So the equation of the tangent line, you could first start it off in point slope form. You say y minus y1 equals m tan times x minus x1. So this is y minus 1 equals negative 12 over 13 times x minus 2. So this is y minus 1 equals, well, distribute the negative 12 over 13 in the parentheses. You get negative 12 over 13x. Negative 12 over 13 times negative 2 is actually a positive 24 over 13, because negative 12 times negative 2 is positive 24. Then you add 1 to both sides. If I add 1 to both sides, this 1 you could rewrite as 13 over 13. And you can now write out your answer as negative 12 over 13x plus 37 over 13. And that would be your solution to problem number 4.